So lesson 8.7, we're going to be looking at multiplying and dividing square roots. So we kind of dove into square roots and cube roots in 8.6, and now we're going to start working with them, multiplying and dividing and simplifying them. And then when we simplify them, we're going to be leaving them in what's called simplest radical form. And we'll talk about how do we do that? Why is that more important than just plugging in the calculator and getting some nasty decimal? How is it more useful? We call that an exact answer. Okay, so we're going to jump into all that. So today's big idea says, just like powers, square roots distribute over products and quotients. So products being when things are being multiplied, and quotients when things are being divided. So we can distribute the square root to everything that it's underneath, just like we can distribute a power, like a square, to everything that's inside, say, parentheses. Or if an entire quotient or a division problem was inside parentheses, you could distribute that power as well there. So it's the same idea when we're looking at square roots. So the product of a square roots property says that when you have the square root of a times the square root of b, we can rewrite that as the square root of a times b. And vice versa. So if we had the square root of this times this, we could split it up into two pieces. So let's prove that this is true. If we had the square root, we'll pick some nice numbers that work out. Square root of 25 times the square root of 4. First of all, we know the square root of 25 is 5, because 5 times 5 is 25. And we know the square root of 4 is 2, because 2 times 2 is 4. So the square root of 25 times the square root of 4 is really just 5 times 2, which of course we know is 10. But if we're following this property, square root of a times square root of b, we've got here equals square root of a times b. So if I did 25 times 4, I get 100. The square root of 100 is 10, because 10 times 10 is 100. So this quick example right here proves that this property holds true. So the actual numbers that you get from the square roots, if you multiplied them, give them the same answer as if you multiplied these numbers that are inside your square roots and then took the square root at the end. So you either take the square roots early or you take the square root at the end. Either way, you're going to get the same answer. And depending on what these numbers are, most of the time they're not such nice numbers that you can just simplify right down to whole numbers. Because if they were, then that's probably the easiest way to do it. But they're not always going to be like that. And so this property is going to help us simplify things that aren't quite as easy as when we see them in the future. Quotient of square roots property, very similar. The square root of c divided by the square root of a, and you can use any letters there, of course, equals square root of c divided by a. So it's basically, if both of them are being square rooted, you could put the whole thing underneath, or vice versa. If you saw a fraction that was being square rooted, the entire thing, you could split it up into two separate pieces, because maybe one of them will simplify nicely and the other one will not, and so that will help you simplify these things along the way. So quick example here, if you had the square root of 64 divided by the square root of 16, following the property, that should be the square root of, now this says that you're dividing the two. So you're taking this number and dividing by this number. That's what this says. So 64 divided by 16 is 4. So far I've actually used this property, although this doesn't look like a fraction. So you might say, well, how come you didn't put 64 over 16 right here? I did. 64 over 16 is 4. It's just simplified down to that. And we know the square root of 4 is 2. So the answer to this is 2. Just like if we would have said, well, I know the square root of 64, that's 8, because 8 times 8 is 64. And I know the square root of 16 is 4, because 4 times 4 is 16. And then 8 divided by 4 also gives me that answer. So I can divide these bigger numbers and put it under the square root, or I can square root them first and then divide. So this property can kind of go back and forth between the two. So let's jump into example number 1 and start using this. So you can see here, this is already split up into three things being multiplied, so products underneath the square root. And so going the opposite direction, so right now we have this. We have things underneath the square root being multiplied. We can go back and we can split them up. So this actually would be the same as the square root of 36 times the square root of 81 times the square root of 100. And instead of working with those big numbers like that, we know the square root of 36, it's 6. And we know the square root of 81, it's 9. And we know the square root of 100, it's 10. Because 6 times 6 is 36, 9 times 9 is 81, 10 times 10 is 100. So 6 times 9 is 54, times 10 is 540. And you'll see that one in your homework again. So same idea here. If I've got a product underneath my square root, I can split these up to help simplify. I'm going to split all three products up under their own square root and see if I can't simplify them. Now, sometimes they're not all going to simplify. You're going to have to leave them as a square root. We'll talk about that in a second. But this one does, because the square root of 9 is 3, because 3 times 3 is 9. Now, what about the square root of x squared? What number or what variable times itself gives you x squared? 3 times 3 is 9. What times what is x squared? It's actually x, because if you think about it, x times x is x squared, because when you multiply these, we know with that product rule, you're going to add your exponents. We know 3 times 3 is 9, and so for y squared, y times y is y squared. So the square root of y squared is just y. So these are all being multiplied, and you can simplify this all the way down to look like this. Now kind of go in the other direction. So for these two, we were starting with all the products underneath the square root and then splitting them up. So now they're split up, and it may help to simplify these to actually put these together. So I'm going to put all of this underneath, 7m times 7n, which can be rewritten as 49mn. I can multiply those two numbers together. And now if I want to, I can split this up. So that's the square root of 49, which is helpful. That actually has a nice number, times the square root of m times the square root of n. So square root of 49 is 7. 7 times 7. Now, be careful here. You might say, oh, square root of m is m. When we were doing that over here, that's when it was actually squared. So something times something is m. Well, we don't have that. Okay, so we can't do anything with this. We're going to leave it as square root, and we have to leave this as square root. And so we're going to actually have to leave them both underneath. And this is going to be your final answer. So now that looks goofy, right? You're not used to leaving an answer with a square root in it, but if it's variables in there, or even if it's a number that doesn't have a nice square root, you're going to leave it like that for a nice exact answer. And so what this is called, and they're going to say simplify the square root, sometimes the directions are going to say put it in simplest radical form. Simplest radical form, you'll start to see that a lot. That's when you leave a square root in your final answer, because you cannot simplify that square root anymore without making it a decimal. So what we're going to do is we're going to try and split these into pieces using that property, simplify them as much as we can, but a lot of times we're going to be left with something being square rooted in our answer that does not have a nice whole number for its answer, and it would be a decimal that we'd have to round to really work with, and we never really want to round. And so we're going to leave this as an exact answer. So you're going to see that a lot. It says find the exact length. And so these are exact answers. Whereas if you find the decimal and you round it, it's not exact. So it's like leaving a fraction as an answer instead of dividing and getting a decimal and rounding it. The fraction is the exact answer. A rounded decimal is a little off. Same thing here. A simplest radical form is an exact answer. It's something you can use because it represents the number exactly. Whereas if you rounded a decimal, you've actually changed the number slightly. So here's the process. This is called simplifying things into simplest radical form. You're going to take whatever number is underneath the square root and you're going to try and split it into pieces. And those pieces, ideally, one of them or both of them is going to have a number that actually gives you a square root. So here's what I mean. We can split 40 into 10 times 4, right? We know that 40 is 10 times 4. And this property says that we can do that up here. So we're going to split this now into square root of 10 times square root of 4. Now, why did we do that? Well, square root of 10, there is no square root of 10. I mean, it's a decimal. There's no nice whole number, square root of 10. But there is a square root of 4. What times itself gives you 4? 2. Now, square root of 10 isn't going anywhere. And you could try and split that into more pieces. You could say, well, isn't square root of 10 square root of 5 times square root of 2? Yes, it is. But the square root of 5 is not a nice number. The square root of 2 is not a nice number. And so we're going to leave it like this. We just keep trying to split it into pieces to see if I can get a whole number square root. This is as far as it's going to go. It's fully simplified. So here's how you write your answer. You're going to put the whole number in front of the square root and write it just like that. 2 radical 10 is the way you could say that, or 2 times the square root of 10. But we can start using this word radical. Okay, it kind of just represents your square root. So this is read 2 radical 10. All right, square root of 50. Let's split that into 2 pieces. And we can start going straight to this if you want. So I would split this into square root of 25 times the square root of 2, because I chose that purposely because I know 25, not only does it go into 50, but it's got a nice square root. Square root of 25 is 5. Square root of 2 does not work out nicely. Okay, so I'm done here. So it's 5 radical 2. Now I want to show you what this looks like in the calculator just so you can see what we're actually doing here. So if you try to take the square root of 50, you got your answer. It looks like this. Okay, square root of 50 is not a nice number. So these should be equal to each other. But if I was going to try and use this, it'd probably end up getting rounded. And so I'd rather have the exact answer. So I'd rather use 5 radical 2. So let's actually punch in 5 radical 2 and prove, okay, square root of 50 is equal to this. 5 radical 2 is equal to this, which means all of these numbers actually say the same thing. So this 5 radical 2 is a simplified version of radical 50. Think simplified fractions. Same idea. It's a simplified radical. They're both equal to the same thing, but these nasty decimals are not useful to us. So we want this exact answer in simplest radical form, 5 radical 2. Okay, so let's try a couple more. Looking at 60, you might say 30 times 2. But if you look at 30 and 2, neither one of those have nice square roots. So you want to look for something that does have a nice square root. So I'm going to go with 4 and 15. 4 times 15 is 60, and the square root of 4 is 2. And that's going to just leave this radical 15 there. Looks like this. Now let's say you started with radical 30 times radical 2 because you said 30 times 2 is 60. And you get here and you say, well, neither one of these have a nice square root, but I can keep splitting 30 into more pieces. So this 30 can split into 15 times 2, and then I still have this times 2. And what happens is when you take the square root of 2 times the square root of 2, that property from our last unit says that that's just going to be 2. Because if we use our property that we've got there, when I actually multiply these together, it's going to be the square root of 4. So I have square root of 15 times the square root of 4. Well, this becomes the 2, and here's your square root of 15. So it's not that this is wrong, this just creates more work. If you can ideally split this into things that automatically simplify right away, it's going to make your life more easy. Whereas here, this will get you to the right answer if you know what you're doing, but these are going to take more practice to really get it right. Whereas if you initially right off the bat pick a number that's got a square root, it's going to get you off on the right track. Now, when you get to here and you actually had the 15, you are going to want to split that into pieces and see if there's anything that fits into that nicely. The numbers that you're really looking for are 4 and 9 and 16, okay, and 25 and 36. So numbers that have square roots. So it's a real quick, easy check. When you're looking at 15, you basically, the only numbers smaller than it that are perfect squares are 4 and 9, okay, because square root of 9 is 3 and the square root of 4 is 2. Those are the only ones we're looking for, and since neither one goes into 15, we know we can just leave it like that. All right, so here's the quotient rule. Square root of 40 divided by square root of 10. When you go ahead and you divide those, that comes out to the square root of 4, and that is 2. So that works out nice. All right, last one, example number 3. So we're going to put this to the test now. We're going to go back and do a Pythagorean theorem problem, and we're going to use this simplest radical form to find the exact length of the hypotenuse. So we're not going to round it to a decimal like we did yesterday. And all we're going to do is get our answer in simplest radical form. So it says each leg of a right triangle. So draw a right triangle. It means you got a 90-degree angle, and your right legs are the legs that are coming out. And they said they're both 8 inches. So these are equal to each other. Find the length of the hypotenuse, which remember is out here. So I'm going to label that C because we always say this is A and B, and that's C. So we should know now a squared plus b squared equals c squared. We're going to plug in our numbers. 8 squared plus 8 squared equals c squared. This is 64 plus 64, which is 128. And then at this point, if I'm trying to find out what c is, I need to take the square root to turn this into c. In an equation, you always got to do both sides. And so c equals the square root of 128. If you put that in your calculator, and you're wondering, is there a square root of 128? There is not an exact whole number that goes into 128. And so we're not going to round our answer to the decimal. It says find the exact length. So this could be it, but we want to start testing, are there numbers that go into it that we can split this into and simplify it? Now you got to think of those magic numbers that have square roots, like 25 has a square root and 36 has a square root because it's 5 times 5 or 6 times 6. If you just think back to this right here, 64 is one of those magic numbers because 8 squared is 64. 8 times 8 is 64. So since we added 64 and 64 to get 128, that means 64 times 2 is 128. So I'm going to take my 128 and I'm going to split it into two pieces, the square root of 64 and the square root of 2, because 64 times 2 is 128. And the reason I chose that one is because I know 64 is one of those magic numbers. It's called a perfect square that has a whole number square root. So the square root of 64 is 8, and there is nothing I can do with the square root of 2. There's nothing I can break it into that has a nice whole number square root. And so this right here is your exact answer. And remember, this is called simplest radical form. All right, so anytime you're doing one of these problems that has a square root answer, it'll either tell you round to the nearest hundredth or something like that. Or if it doesn't say round, it'll say find the exact length. This is the answer we're looking for, 8 radical 2. Just real quick, again, if I plugged in 8 radical 2, notice I get the same exact answer as the square root of 128. Okay, so these are equivalent. It's just the simplified version. And instead of rounding this to 11.3, I now have an exact answer that in the real world, if you were building something and you're going to use this number to go calculate something else, we need the exact number. We don't want a rounded amount that's going to throw off our answers later. Okay, so there's multiplying and dividing your square roots.